What's up, you scholars of enlightenment? Scientists claim to have unearthed a stunningly preserved leg of a dinosaur, complete with its skin, along with other intriguing fossils from the Tanis fossil site in the US state of North Dakota. Now, as if such a finding were not fascinating enough, what is most intriguing is that scientists claim that the creatures unearthed at Tanis were killed and entombed on the actual day that a giant asteroid struck the Earth about 66 million years ago. The asteroid that effectively ended the reign of the dinosaurs and facilitated the rise of mammals and eventually us. So to help us dig into this, pun very much intended, and these fascinating findings, we welcome back Dr. Michelle Thaller to the show. Michelle, how are you doing?
Hey, doing very well. Yes, it was quite exciting week at NASA. So many great things going on. This one just came literally out of the blue.
Amazing. You definitely get up to a lot of fun stuff. So Dr. Thaller is an astrophysicist with over 2 decades of science communication experience, and her research involves the life cycles of stars. She's worked at the Jet Propulsion Laboratory, the Goddard Space Flight Center, and she's appeared on many television science programs as well. And she's now NASA's assistant director for science communication. So last time we spoke and we talked about James Webb, we talked about, what else did we talk about last time? I forget.
I think that was the big one. Yeah, I mean the Webb launch, I mean all of that commissioning, all 300 and so single point failures that we watched go off, and we were all just sort of calming down. And
we talked about Arendelle as well. That's right.
We talked about Arendelle. That's right. The farthest star ever seen, as we see it 12.9 billion years in the past. Incredible.
Exactly right. And you mentioned when we spoke last that you had an outreach activity that was coming up where you had to wear a full body Triceratops outfit. Now, I assume that costume was related to these findings.
Well, let me just say that it wasn't a case of me having to wear. I mean, NASA certainly did not require me. The nice thing about being somewhat senior in your career, sometimes they just can't stop you from things like this. So, I mean, some of the things I've done is I have had my official NASA badge portrait done in a Star Trek costume, Star Trek Next Generation costume. Nice. I showed up on the day I was getting my picture taken and said, are they really going to stop me? The answer is no. And you know, if you want to meet the guests that are coming to talk about all these amazing science results, and you happen to have a large inflatable Triceratops costume, the answer is anyone actually going to stop you?
As you do. As you just have one, and it's fine.
As one does, right? I mean, these are amazing. A lot of people have the inflatable T-Rex costume. You've seen that on all kinds of videos.
I've seen the little body one where with the.
That's right. I mean, these are not that expensive. I mean, I think I paid like $79.99 for it. But the Triceratops is even better. It's huge. I mean, so your feet are in the front legs of the Triceratops, and then the big back and tail behind you, and then the head. They have a little sort of Velcro strap that supports the head. It's great.
So it sounds like you had a lot of fun with that, and amazing. So what is actually going on? So I've got the link up here from the BBC website. There was a lot of coverage of this. It went all around the world, very well received. We talked about that offline that there was an Attenborough documentary. So that's when the gravitas is really coming to the fore when Big Dave is getting involved over here in the UK. What is going on at Tanis? Because the only Tanis I've heard of was on Indiana Jones and the Raiders of the Lost Ark, I think. So it was an ancient Egyptian city where they buried the Lost Ark, I think. So what's the deal at Tanis here? This is a fossil dig site in North Dakota?
That's right. And I'm so glad I wasn't the only one that got confused, because the person that set this up at NASA is one of my heroes. He's one of our senior Earth scientists named Compton Tucker. And Compton, in his spare time, his vacation time, actually does go out to Turkey with a magnetometer to find unaltered tombs before tomb robbers get to them. Amazing. And he's kind of a modern day Indiana Jones. He helps preserve these things for science. And so when I first heard this Tanis 2, I immediately thought of Indiana Jones. I was wondering if he was in the Middle East. But no, Tanis is actually a site in the Hell Creek Formation of North Dakota. So North Dakota, there you go, nice map there. North Dakota has some of the most incredible finds, the most intact dinosaurs that we've ever seen on the Earth. And people have known this for decades. I mean, a lot of the really, really famous examples of Tyrannosaurus Rex, Triceratops, et cetera, these big dinosaurs come from there. Yeah. And so people have been working at this site for a long time. But there was one area, and that's sort of in this Tanis area that was named. I don't know who named it Tanis, by the way.
I really hope it's an Indiana Jones reference, but I don't know. I don't know that. I don't know that that's true, but I'm just hoping that it is.
It's paleontologists, archaeologists.
Exactly.
There's probably
exactly.
yeah.
There's
Anyway,
probably something going on there, but maybe not. Maybe it's just called that by chance.
That's right. That's right. So they told the story that this part of the dig area, people were working all over, different universities, different consortia. They sort of avoided this one area because it seemed very difficult, kind of jumbled and confused, and they figured it wasn't anything that was really a great place to excavate. And they saw in this kind of jumbled area that there was some skeletons of fish. And this man, Robert De Palma, which you see there, is very, very fond of excavating fish and very fond of studying ancient fish fossils. And so they basically said, come on over here and have a look. So Robert is affiliated with the University of Manchester.
Yeah.
He's getting he's finishing his doctorate there right now. And there was people he was working with from.
I've got to say, he's got the hat as well. I mean, look what's going on.
Not only does he have the hat,
he's done this on purpose. I don't know if this was the photographer was like, wear this will be good, or whether he just wears it all the time. But he's got the look going. He's got the look down. It's excellent. I like it.
It's even better than that. If you watch the documentary, maybe you can see if you really expand the image. He actually has a scar that goes over an eye.
Amazing.
And his eye is intact, but the scar actually, I think it would probably be, you can just see a little bit of it on that image. He has the scar that goes across his eye, and when he came to NASA, he wasn't wearing the hat, although he had it. He had it like to go outside, but he was wearing this sort of black vest, and he looked. I was like, holy cow! I mean that's somebody that really I love people that have that sort of character, and so anyway so Robert starts excavating his fish, and he's a grad student, right? I mean he hasn't been given the best part of the dig. That's how it works.
Yeah.
And as he starts excavating these fish, he realizes there's something really, really unusual about these skeletons. And I can, if you want, I can go through some of the things that he saw right away.
But please do, because there's some really interesting things about these fish. These are really the key finding here that links it back to this asteroid, this potential timing of the event, isn't it?
That's right. So the fish were incredibly well preserved. They had died and been buried very quickly. There'd been no rotting. I mean, he actually brought some of the fossils. Amazing. And he noticed that the gills, that what had actually killed the fish, were all of these little tiny glass beads were stuck in the gills of the fish. Now that's these glass beads were a form of obsidian, of a volcanic glass, and that's that could either mean okay, well maybe a volcano exploded nearby, lots of volcanic debris killed the fish.
Incredibly high temperatures and pressures, I guess, to create these.
That's right.
This
to actually melt rock and then actually melt rock into glass. Yeah. And then the idea is that the rock is launched into the air. And as it in a melted form, and as it falls back to Earth and cools, it forms these little beads of glass. It's the same thing as how they used to make like shot. That they used to drop shot lead from a tower, and as it falls, that's right, it forms little balls. And so this is basically natural glass shot coming through the atmosphere. Yeah. And so that was
glass bullets dropping down on your head, which doesn't sound like the nicest thing to be happening, But then again, if a massive asteroid has struck the Earth, there's going to be some not good things happening, I guess. So
I'm amazed anything survived that day. It's incredible to think that you and I are here talking because our ancestors lived through that day, right? So, some little tree shrew somewhere, hit under the debris, and that's why we're here. I mean, our great billion times great grandparents lived through that day. But at any rate, so that was interesting. Fish killed by volcanic explosion. Then he starts to excavate the fish a little bit broader, and he sees all these skeletons piled on top of each other. Yeah. And some of them are freshwater fish, and some of them are really not. Yeah. They don't belong there. There are sharks. There are shellfish from the ocean. There's all kinds of freshwater fish and saltwater fish, all jumbled together, all killed together. And so that was like, okay.
It's like to take a phrase from Aliens, it's like a goddamn town meeting. There's just all these different weird creatures that probably shouldn't be together in the same formation in the same rock layer, and they're all just thrown together somehow for some reason.
That's right. And then he starts to look at the sediment, the actual sediment that was laid down by the river. So I noticed you had a picture there of what North Dakota, what North America looked like during this time, and there was a big waterway that connected to the ocean that separated basically in half the continent. Yeah. And so, so North Dakota had these river systems. The Tanis site was not. I don't know if this could be a little bit of my misperception, but what he had said is that it wasn't exactly on.
I didn't clock this when I was just quick scrolling, but I was like, yeah, this doesn't exist nowadays. I didn't clock it when I was going through, but I should have done. I was like, yeah, this isn't a thing that is there right now.
Well, it's funny. I mean, just a little bit of conversation about that. Of course, yes, we do not have a large saltwater waterway that cuts the North America in two. If global warming continues unchecked and ocean level rise goes up as much as we think it may, we will again.
Interesting. Okay. All right, we'll go with that. It's what
that will come back.
May come back to being again. At the moment, it's not there, but it might come back.
Well, I mean, you can see how much higher the ocean level was at this time. So I mean, the Cretaceous era was much warmer than it is now on average. In fact, the carbon dioxide level, I think, was nearly twice what the CO2 level is now. And so, I mean, you didn't have these big ice caps, these big glaciers. So the ocean level was naturally much higher during that time. And then, like I said, if we return to that, then we'll have that wonderful waterway again. But at any rate, so the sediment all around all these jumbled skeletons that shouldn't be together told a really amazing story that there had been two big waves wash the wrong way up the river. Okay, the river basically was flowing from west to east and draining, and something came by up this river that actually reversed the flow of the whole river. And there were two of them. There were two huge sloshes. And that's coming from the direction, if you see where that little circle is with the arrow, of where we believe the impact site was that ended the Cretaceous period and killed pretty much all of the dinosaurs and everything else that day. And so these skeletons are at the right time geologically, what we call the KT boundary, where we see all of this debris that fell down everywhere around the Earth that we link to this asteroid impact site. There you go.
I think we see this sort of nice dark layer, thin dark layer, don't we? Where they
that's right. So we for a while. I mean, the KT boundary has been known about for a long time. What was controversial is, could it be just lots of volcanoes went off? Other extinctions we think were caused by big eras of volcanism. Or did something from space hit? And I mean, one of the things is that there was a lot of iridium in this layer that got laid down everywhere across the Earth. And that's present both in some volcanic rocks and in asteroids. So that doesn't necessarily mean one or the other. But here's where the find starts getting even more amazing. Okay, so two giant waves came by. North Dakota was still 2,000 miles away. I'm sorry, I should say kilometers. It's like 3,000 kilometers away from the impact site. And so it wasn't so much that it was a tidal wave that went that far, some kind of big tsunami, but there were seismic waves, that huge seismic waves. They talked about earthquakes, the equivalent of 11. Where, I mean, think about that. I mean, a huge earthquake is like a magnitude 7, and then the Richter scale is logarithmic, so it's 10 times more.
So that's like 10,000. So what, to get from 7 to 11? What's that? So that's 10, 100, 1,000, 10,000 times.
Yes, thousands of times stronger than than the biggest earthquakes we know of. And so the idea is that the seismic waves basically sloshed the waterway, all the way up. And so that was what had happened, and so that's really cool. I mean, so we have got giant waves. We've got I'm sorry, my computer's doing something weird. I'll just we've got giant waves. We've got things that freshwater and saltwater creatures jumbled together. They were killed by rains of glass from the sky, and then but here's where all of us. I mean, I actually looked. Next to me, the chief scientist at Goddard Space Flight Center, Dr. Jim Garvin, was actually getting tears in his eyes because along with all these sea creatures that were washed together, there were trees. There were big trees that had been uprooted. They were sort of a type of pine tree. and they had sap, as they were being smashed apart. The sap was forming little droplets, and fossilized sap becomes amber. And of course, a lot of people know amber
from Jurassic Park. We know we
Jurassic
get
Park.
we
That's
get our
right. Yes, you're gonna
mosquitoes.
get DNA. Yeah, yeah. Well, it's not that they didn't get DNA of the dinosaurs, at least not yet. But trapped in the amber were little unaltered bits of basically asteroid. I mean, it has extraterrestrial abundances. They did all of this. In fact, they went to the particle accelerators, one in the UK at Oxford, and the other one, I'm trying to remember. Oh yeah, Berkeley, the Berkeley Linear Accelerator. They did all of the chemistry of these things in a non-destructive way, and in this amber, we think there are preserved little bits of
little inclusions. I think they call them, of very
asteroid.
high levels of iridium, hundreds of times higher than we would expect from Earth rocks, things like this.
Exactly. The abundances of these rocks don't match what a volcanic rock would be. This is basically the smoking gun that there was a big pulverized asteroid.
And this is absolutely amazing, isn't it? Because we've had a sort of indirect scientific idea that this is what happened. We had this impact crater. We see the KT boundary, so it's always been, or at least since I was young, it's always been the sort of leading hypothesis as to how the dinosaurs met their end. But now we literally have something that looks like it's direct evidence of what happened on that day, which is crazy when you think about that span of time, 66 million years. You can pick that exact day or a very narrow window around those days. It's incredibly precise, and it's just one of those things where, I don't know, it gives you an odd feeling in the sort of pit of your stomach to be almost seeing. I think De Palma described it as almost sort of like a show reel of what happened just before those events. It's as close as you're going to get to having a movie of what happened on those days. It's
oh yeah,
amazing.
and the Goddard scientists were there's so many things they want to know, the stuff that's trapped in amber, because there may be little bits of gas from the atmosphere that day. I know Gavin Schmidt, our climate expert, thought that this set off so many fires around the world. They wonder if all the oxygen, if seriously, nearly all the oxygen was sucked out, combusted by the fires. There are bits of pollen preserved. I mean, and then you go into the fact, okay, now we've established that these dinosaurs were most likely killed the day of the impact. The preservation, so you mentioned a bit about this, that now you've got all these things that were killed quickly and buried. And so very little decomposition, and remnants of the skin of a triceratops. I mean, of course, it's fossilized. I mean, it's so long ago. We're not talking about actual, like cells living still. But the incredible thing is that it was so well preserved. They're actually identifying compounds, molecules, basically, inside the skin that they know are actually from the original animal. Wow. I mean, yes, it's turned back into rock. Turned into rock, but inside the rock specifically, there was sulfur and other things, potassium, that they can identify from actually being part of the animal. And then you're showing this amazing fossil, this egg of this baby pterosaur, and a big one too. I mean, the baby was about the size of a bat, they think. So this was going to grow into one of the pretty big, flying dinosaurs. They weren't dinosaurs, they were pterosaurs. I get that, but this was so well preserved, and they do not have an existing skeleton of the species, and there you see it was about a bat, and it was this thing was just about to hatch. Poor little thing. I guess probably nobody had a good day.
Probably better to not be around at that time.
Yeah. Yeah, but in the bone structure, there are preserved compounds that were actually organically attached. They were part of the little creature. So I mean, yes, the rock seeped in and rock made a fossil, but inside the rock there are actually still molecules from the original beings. Wow. So it's not just a pure rock. I mean, this is a preservation of some of those little, and some of those big creatures.
So as well as getting information about maybe the atmospheric levels there, the composition of the asteroid, we're also getting some more information about potentially the chemical makeup of these animals. Even in this case, what they might have looked like, some of their size measurements possibly as well. So there's a hell of a lot of interesting science that can come out of this site, not just not just the sort of almost human aspect of it.
Oh, and they're just starting, right? I mean, and they're in this race against time because, I mean, as these things are exposed to the air for the first time in 66 million years, they begin to degrade.
Yeah.
And so, sorry, that would be a cat. And so, they're all like, quick, everybody get to Tanis and just start excavating, because, they want to make sure they preserve as much of this as they can. And again, it's this wonderful irony of this particular part of the whole area that didn't seem very promising, given to a grad student. Here, somebody look at these fish.
You mentioned, and then it was like, you mentioned, of course, the leg, and I think, I think they said it had even been ripped off so violently that they think this was literally the force of the impact, or the the seismic waves and the tremors that happened. Incredible violence. Now there is some slight pushback of people saying, oh well, maybe these were dead things that were then thrown together, but still you're in that very close window, regardless of which one of those it is. You're in this very, very close window. I think they mentioned a fossil that literally had like a wooden stake thrown through it, which again is suggestive that things were just getting thrown around and there was this sort of huge upheaval. So it all sort of points in one direction, but regardless of what exactly happened to these individual fossils, it must be very close to that time.
Oh yeah, I mean, scientists are skeptical by nature, and that's a good thing. I mean, so I mean, when I heard, oh, they think they found some dinosaurs that were killed the day of the impact, you're like, well, why would they think that?
Yeah.
I mean, what's this is a pretty amazing, ideas. So I mean, it's the idea that I love that Carl Sagan quote that for really incredible claims you need incredible evidence, or I mean something along those lines. And so we were all we all sat down to listen to the seminar, and we were all like, oh, neat, and then we were like, oh,
yeah, show me the evidence. Oh, there's the evidence. Okay.
And the seminar is public. It's online. Yeah. I can send you a link, and you can include that if people want to watch it.
Yeah, definitely.
And I mean, you can just see that they were ready for our questions. They're like, okay, bang, bang, bang. Oh, that question. Here we go. Bang, bang, bang. And so, they knew what the questions would be. And I mean, of course, there's no way to say 100%. You can't. But
I mean, when do we ever say 100%? I don't think people even say like Einstein is right 100%. Right? It's what we never do it in science. We're always, in some ways, it gets us attacked in some ways because it makes us look like we don't know what's going on sometimes. But it's the correct response, isn't it? To say, look, all the evidence looks like it's leaning this way. It all makes sense. There's great parsimony here, but there's still a chance that something odd could have happened that we can't fathom. It's just the nature of science.
It's just one of these cases now where if it's anything else, it's gotten to be highly unlikely.
Yeah.
And and that's when scientists say, okay, that's basically what we're going to call
the lead theory.
Yeah. So that's but I mean, I like the fact that we never have 100% truth, because that's and you're right. People don't understand that about science. I mean, get disparaged for it. Like I'm thinking about like climate science. Like 98% of scientists agree that climate change is caused by human emissions. Yeah. That's as close as you ever get to saying we're absolutely certain about it.
Yeah.
And that's I remember there was I think it was a Stephen Colbert episode where they had sort of like the idea of how this is presented. They had like one scientist that said, well, maybe it's not caused by human emissions, and then we're gonna have a debate, and here's Bill Nye because they're always like picking Bill Nye up and saying, here, debate Bill Nye.
Yeah.
And then Stephen Colbert said, to make this realistic, now we're going to bring in the other 97 scientists, and so they had, they had 98 people on one side all showing evidence, and then one person going, well, but what about this?
This is the thing, isn't it? People talk about balance, and we always want balance and to hear different ideas, but balance is having 98 times having the consensus view on, and then 2 times having the 2% oddball view on. It's not 50-50, but people immediately think that balance is 50-50, which is not always the case, because it's not like you either win the lottery or you lose the lottery. It's 50-50. There's various probabilities at play that are hidden. The amazing thing about this, I as soon as I saw this, it's almost like a sort of dinosaur Pompeii, isn't it? We had the sort of situation with people might not be familiar with the Vesuvius eruption, a couple of thousand years ago. We have these, I don't know if they're fossils, they're sort of encased humans who were sort of covered in ash in their homes and going about their business. So they're in weird poses or just sort of look like they're trying to shelter from this devastation. So it's almost a kind of similar thing. I guess the animals aren't caught in sort of these sort of shocking.
They almost are. They're kind of. I mean, the people of the Pompeii as well are jumbled up and thrown flat. And I mean, I've been to Pompeii. It's incredible because you see some of these, people that were preserved in ash, and I mean the bodies have rotted away, but they left basically their three-dimensional form in the ash, and I mean you can see the buckles on their belts. And sometimes pretty awful expressions on what's left of the impressions their faces left, and you feel really terrible. I mean there are people crouched and trying to shelter, and yes, I mean but the reason these people were preserved, quote unquote, is they were just covered with ash immediately, and that appears to be what happened to a lot of these creatures. They were just covered by this huge slosh, these huge waves that came up the waterway. As they were being rained on by glass that included asteroid bits. Yeah, that's amazing.
Yeah, it's not your best Friday afternoon experience, but very, very interesting from a scientific perspective. And as you said, as sort of macabre as it is, this is what sort of led us to be here. So in some ways, we have to kind of is part of the history, and in some ways we have to feel lucky for it, if that's the right word to use. It facilitated us actually being here, so it's something that we need to understand and investigate as much as we can. And we can't rule out that something like this might happen in the future. So yeah, very, 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 very interesting. And yes, I'll definitely put a link to the full seminar down below, and people can take a look there. I've got to ask you one more question before we finish up. Which is kind of very much up your alley. The decadal survey came out. Any quick hot takes on decadal survey?
The decadal survey of astrophysics or planetary science? Because the planetary science.
Either then. So I've only seen the planetary one, but
okay. So so I know the planetary science one came out this week. I haven't had a chance to read it yet. I did read the astrophysics decadal,
okay.
and that one came out a couple of months ago. So you're one step ahead of me on the planetary one. I will read that. Anyway, so let's keep it to the planetary. Tell me your impressions of the decadal report.
So very, very interesting. I've got a talk set up with I don't know if you know Paul Byrne. And also one with Lee Fletcher next week, because the focus is Uranus, apparently, with all the incumbent jokes that will come along with that, of course. So it looks like outer planets is going to be the focus. So the biggest thing, obviously, was finishing off Perseverance, so making sure we get the samples back and these kind of things. And then the main suggestion after that was outer planetary stuff. So basically Neptune.
I'm really glad about that, because I mean, to think about the fact that there are two major planets, right? I mean giant planets. We call them the ice giants because they're so far out there and they're really cold. And we've only seen those planets as we flew by with Voyager. We didn't stop. We didn't orbit. We were like, hey, zoom, and we took pictures as we went, and that's
1986 as well. So it's been a while.
So I mean, two giant planets, and out there's also these clues about what happened in the early solar system, because we actually think that I tend to say Uranus, and I mean I can say it any way you want, and believe me, I taught astronomy. Yeah. And so before I teach astronomy, it's like, okay, let's just all get this out of our system, right? Okay, Uranus is blue because of methane.
That's what Paul said. He said, lean into it for now. We'll get it all out of the way, and then we can go. Yeah.
Yeah. Well, there's evidence that Uranus and Neptune may have switched places while Jupiter was busy knocking all the inner planets around, and that's an amazing new view of the universe and the solar system, I should say. that in the early part of the solar system, the big planets moved around, and all hell broke loose. But also things like water and organics got thrown into the early inner solar system, which was very hot and dry. And so once again, you're talking about just like this. You're talking about a cataclysmic event that is horrible and destructive. May actually be responsible for us being here at all.
Yeah. And I think one of the points that came up when I was having a quick read is that a lot of these, or the dominant scale of planets, exoplanets that are being discovered, are in this sort of 3-4 Earth size, which is around, sort of Neptune, Uranus. So understanding those better could also give us a better understanding of potentially exoplanet formation models, things like this. So there's a hell of a lot of reasons. Obviously, a lot of scientists have sat down and discussed why we should look into these things. But there's a hell of a lot of good implications of understanding more about Uranus and Neptune. The fun fact that people always like to point out about Uranus is that it rotates on its side, right? So we think it got clattered by something, another cataclysm at some point, and it seems to rotate sort of in the plane of the.
If you had people, I mean, Uranus doesn't have a solid surface, but if for some reason you had like people that were living on Uranus and could see the sky, there'd be no chance of them figuring out the solar system, because I mean, you'd see the sun like spiral in one direction and then spiral in the other, because the whole thing is rotating, not with the plane of our solar system. I remember teaching people, about Uranus and saying, okay, tell me what the sun does in a year, in a day, and they're all like, oh. Crap, I mean, it's really, and then the moons are going the same way, but all the planets are going it's awful.
All these weird retrograde motions and stuff.
That's right. So I mean, they would never have figured it out. I mean, poor Copernicus, and Kepler and all. I mean, they would just be up a creek. So, I mean, those are fascinating worlds. And yeah, as you mentioned, I mean, I think this was rather snarky of the universe, but it turns out that the most common type of planet in the universe so far that we found, because now we know of over 5,000 exoplanets. The most common type of planet is one our solar system doesn't have. One that's about 3 to 7 times the mass of the Earth. And is that more like a big Earth, or is it more like a smaller Neptune or Uranus? And we don't know. And I mean, just give it to the universe. Just the most common one. Nope, not one. You know what? Totally different. Thanks a lot.
But then you get people coming out and saying we're incredibly special. Oh, look, it looks like we were designed here to be different. But it's really interesting. So I think when I was reading it, they were saying we've got a good general consensus on planet formation models for sort of Jupiter-sized planets. We've got good planetary formation models for planets of inner small rocky planets like ourselves, like the Earth. And then in between, as you sort of alluded to, there's a sort of grey area as to, do we project up from the Earth into this area, or do we project down? And what is the sort of interplay between those two? And why do things not just run off if they're Uranus-sized to be Jupiter-sized? And this is all a little bit of a black box, a little bit up in the air. So knowing more, finding more out about these outer planets could have huge implications.
Oh yeah, and I mean, you got things like Neptune has a moon that has liquid nitrogen geysers on it, and then that means it probably has liquid water underneath the surface. And you've got all these amazing moons of Uranus that look like they were smashed apart and reassembled. And so I mean, that also had something to do with why it's on its side, because they rotate in that wrong direction too, around Uranus. So there are huge mysteries out there. And like I said, I can't believe it's been since, like they said, the mid 1980s. And all we did was fly by and say, wow. Yeah, I mean, that's it. Giant.
Is it because it's hard to get to? Has that been part of the reticence, do you think? Because they're talking here.
They're a long way away. Yeah. I mean,
even with the gravitational, even with the grav slingshot here, they're talking 13 years. So
yeah.
Has there been reticence that people are like, it's going to take 13 years, and then what if it doesn't work and it just disappears? That's,
Oh, well, sure. Absolutely. I mean, I, if I, was queen of the NASA budget, I mean, the Cassini mission, I think, is an example where, we hung out around Saturn, for 13 years. It took us like 5 years to get out there. And then we hung around enough to really see the Saturn system in detail and go through some seasonal changes and all of that. And I mean, I'd have a Cassini class observatory around every planet. I mean, I think that that's not even all that expensive, compared to other things that governments do. But still, the idea that we have these two gorgeous giant planets, and we've never even stopped.
Yeah.
I mean, it will take us a while to get out there. They are far away. I mean, I can look. I think Uranus takes about like 80 years to go once around the sun.
Yeah.
Something like that.
Yeah.
And then by the time you get out to Neptune, it's more like almost 200 years, I think, something like that.
Something
so
silly like that. Yeah.
If I can, I used to have them all memorized.
Because it falls the rotational speed falls with distance, and you've got a longer distance to go, so it falls off quite.
It'll take us a while to get out to Uranus. Yeah, absolutely. But yeah, I mean, we got to do it. Absolutely, I did. I mean, it's true. It's a big investment. You launch a rocket and say, "Well, see you in 15 years." But obviously, it'll see things on the way out there too. So
I'll tell you there's always what I've noticed more and more with looking at astrophysics stuff is the opportunistic science. If you can have a look at Jupiter on the way past, if you can have a look at some of the moons on the way past, it will be done. So it's it's not always the things just sort of on hiatus until it gets there. There's more going to be done. That they mentioned there's potential water beneath the icy crusts of a lot of the moons, so potentially looking for different things there. And also the coolest thing they mentioned, and I don't exactly know what it is because I haven't looked it up yet, was cryovolcanism ice volcanoes, which sounds like the coolest thing ever. Can you explain to me vaguely what that is, briefly what that is?
Sure. At these really cold temperatures that the moons are at, ice basically takes on a property more like rock. I mean, ice becomes so hard. Like I'm thinking about like Pluto, right? I mean, Pluto has these mountains that are, I think there's something on the order of 5,000 meters high, and they're made of ice. I mean, they glint in the sun. Wouldn't you love to see that?
That'd be absolutely stunning, I imagine, if you got.
Oh my God! So, when you have that sort of temperature and of water, it actually flows more like lava. And so, you have volcanoes that are bringing, warmer water, but in a very, very compressed and hardened form, up under the surface of these planets. And I mean, the interesting thing about places like Titan, Titan's the moon of Saturn. We don't know that there are cryovolcanoes, ice volcanoes on Titan, but there may be. There are some features we think might be those, and we just need to go and find out more. But Titan has this whole this whole carbon-based geology. I mean, it's methane-based oceans, and the sand is even made of carbon-based stuff. It's raining large organic molecules from the sky on Titan. And then if you could introduce some warmer water, coming up from a warmer layer underneath, and we estimate that Titan probably has about 4 times the amount of liquid water that Earth does, but under this frozen surface, coming up in these lava-like ice volcanoes. And so then you've got organic molecules and warm water coming together. Hey, what might you get?
Might get some life there.
Yeah, and so, I mean, to give you an idea, Voyager just flew by the moon of Neptune, Triton, and just like high zoom, and as it flew by, it saw liquid nitrogen geysers go off. And they think that in order to get that pressure from underneath, there's probably liquid water, under there. So, wow.
Yeah, absolutely amazing. So it's going to be.
Send it now. I want to still be alive.
Yeah, exactly. It's going to be. It's going to be a really, really interesting next decade, and some really interesting things going off. And this is without even saying that having a look at the samples that come back from Perseverance as well. So we're going to have a nice conveyor belt of ongoing science. So really, really interesting to see where that goes. So we're gonna close up because we had a little bit of a quid pro quo. You tell me about fossilized Tanis, dinosaurs, asteroids, and I explained to you the W boson mass measurement. So we're gonna take it offline and discuss that. So yeah, I'm gonna.
This is how I bargain. It's like, okay, look, I'll quid pro quo. I'll tell you all about the dinosaurs.
I give you finest quality W bosons anywhere. Yeah, exactly. I do you good price. Yeah, it's so we're gonna take it offline and do that. But I will make sure all of the links that you sent me, the link to the excellent the seminar that was done at NASA, I'll make sure that's in the description. So if you want to find out more about this this Tanis fossil dig, it's on the BBC website. There was an Attenborough documentary over here, so you know it's serious. And I'll put that excellent seminar from NASA down in the description. So head to those links, and you can find out much more there. Amazing. Thank you so much for explaining that for me and for the people out there. I really enjoyed that.
Oh, it's a lot of fun. We were so happy at NASA about this result. So thank you for having me, and I'll talk to you next time.
Absolute pleasure. Take care.